Hi, welcome back. This is the screencast for Mini Project 2. In this video, we are going to be going through the steps to prepare the community level variable for both two category tests, which include the Independent Samples T-Test, and the three category tests, which includes the Anova, and then both of their non-parametric alternatives. Now, before we get into that, I just want to kind of lay out a couple of things. The instructions file for Mini Project 2 is 22 pages long, and I know that that is very long. I know that this video is probably gonna also end up being pretty long, and I apologize for that. But there's just some things that I need to be able to communicate to you, which are difficult to do unless I type them out. Like, if you think that this is a long, unwieldy document, imagine how much time I've spent building this thing so that you can get a good sense of what you're supposed to do and how to do it. So I don't enjoy making these documents this long, but you know, there are some things that are hard to communicate otherwise, and I'm hoping that, you know, by seeing them written down and hearing me talk about them in the screencast, that maybe they'll make good sense. It's one of those things that we just kind of have to deal with because, you know, we're in this new sort of learning model where, you know, I can't interact often or extensively with you in real time. So we're going to actually just do the best that we can. Okay, so in Mini Project 2, we are going to create a two-category nominal variable, okay? And we're going to use community area for this. We're going to basically take all the community areas in Chicago and break them up into two categories, those on the north side and those on the south side. And then we're also going to do this for a three-category variable so that we have north side, south side, and west side. Okay, once we do that, then we'll do ANOVAs and Kruskall-Wallis H tests for the three-category test, and then we'll do Independent Samples T-Tests and Mann-Whitney U tests for the two-category tests, and that's the bulk of our project, okay, or the bulk of Mini Project 2. Before we get into that, we need to run a few correlations. So where we left off with Mini Project 1 was basically we created new variables, then we did scatter plots on those variables. And, you know, they're great because, you know, like, you know, that old phrase, you know, a picture's worth 1,000 words. You really can see, you know, sort of the relationship between, you know, in your independent variable and your dependent variable in each of those scatter plots. And that's great. However, you know, we're basically eyeballing it there, right? You know, you could just say, well, that sort of looks like a relationship, or that sort of looks like a linear pattern. But we don't really have any like hard and fast rules on whether or not those two variables are related to each other. So like that's what gets us to the correlation. Okay, correlation coefficients are essentially statistical measures of those scatter plots. Okay, and so what we're going to do first, before we get into the ANOVAs and T-tests and Kruskall-Wallis and Mann-Whitney U tests, is we're going to run 5 Pearson's correlations and 5 Spearman's correlations. Okay, now Pearson's correlations, those are the parametric correlations. Okay, they are based on a mean and they have their sort of requirements or parameters, and we get them. Okay, now we're going to cover correlations a lot more in week 8, I think. Basically, you know, we're going to go ahead and do it now, and we're going to get the coefficients, and it might not make a whole lot of sense until you actually cover the chapter. But long story short, a correlation coefficient is a value that ranges from -1 to 1. Okay, values that are closer to -1 and 1 indicate a stronger relationship, and values that are closer to 0 indicate a weaker relationship. The sign also matters here. So a correlation that has a negative sign means it's a negative relationship. So as one value goes up, the other value goes down. Okay, and then correlations that don't have a sign are assumed to be positive, and therefore indicating a positive relationship. As one variable goes up, the other one goes up. Now, With both the Spearman's and Pearson's correlations, you get a significance value, which is, that alpha, or that, the probability that these results were achieved by chance. And with all significance values, we want values that are 0.05 or less, that those indicate significance, a significant relationship. Okay, so let's go ahead and get started. Now, for our data, I already have it open. I'm going to go ahead and get my syntax file open, maybe. I don't know why it's closed. Okay. Now, you'll notice the first part of this is stuff that you should recognize, like it's all like creating new variables, labeling those variables, and then the scatter plots. Okay, so I'm going to start by highlighting all of that and running it. Okay, what this is going to do is it's going to create my new variables. All right, because now, like, I'm just working with my new variables. I'm not playing around with any of my old variables. Okay, and the first thing we're going to do is we're going to do a correlation. Okay, now to get to the correlation menu, you're going to go up to data and transform. Actually, let me kind of just show you this document. So if you wanted to follow along with a document, like I go through all these steps in this 22-page monstrosity, or you could just follow along with what I'm about to do. But I'm going to move this over to my other screen so that we could focus on the actual steps. So we're going to go to Analyze, and then we're going to drag down to Correlate. Where is Correlate? There it is. Okay, and we are going to do a bivariate correlation. Okay, because it's just two variables that we're going to work with. And if you need to, you can always resize the window. And since I've already created those measures, what I need to do is just need to pull two of them at a time into this variables window. Okay, now I'm going to do infant mortality with all my other ones. Okay, so infant mortality and percent foreign born are my first one. Okay, I'm also going to make sure that the Pearson's correlation is selected here, and then I'm going to click OK. All right, and the first thing I'm going to do is I'm going to grab this syntax and I'm going to paste it into my syntax. It is right here. Okay. So as you can see, the syntax for correlation is all like, it's mostly boilerplate stuff here. The only thing that it comes from my data is the IMR 2012-2016 and foreborn 2012-2016. I'm not a big fan of like using that drop-down menu, mostly because it's kind of annoying. So what I'm going to do is I'm just going to go ahead and paste 4 more of these so that I can just swap out the variables here. Okay, the first variable IMR is going to stay the same. All right, we're just going to move. We're going to like go with this no HISP dip question. This is the percentage of individuals in a community area that do not have a high school diploma. Per cap inc is the per capita income. I'm just like double clicking and then doing Control C to copy paste. All right, so what am I doing here? I think I'm like getting out of order here. So the no HISP is actually our last variable, and per cap inc is our second to last, and then the Gini coefficient is our third, so that's Gini. Let's make sure 1, 2, 1, 2, 3. Here we go. Paste. And then the second one was non-Hispanic Black, NH Black, and the first one was foreign born. Okay, so if I just want to take a tiny second and make sure that I have all my variables in where they're supposed to go here. Okay, so I've got IMR and high school diploma, IMR and per capita income, IMR and Gini coefficient, IMR and non-Hispanic Black, and IMR and percent foreign born. Very cool. Okay, so I'm going to go ahead and run these as well. And I just realized that I probably could stand to label that a little bit better because I just said correlations. I probably should have said that these were Pearson's. Okay, that's a parametric test. Okay, so let's have a look at the output. All right. Now the output for the correlation is very it's very repetitive, right? So because there's two variables in the bivariate correlation, it basically does like a 2 by 2 table. But what's crazy about it is that variables are perfectly correlated with themselves. Okay, so like average IMR in the column and average IMR in the row, like you get a Pearson's correlation coefficient of 1 because something should be perfectly correlated with itself. And then you have the same situation down here. Okay, so it's really goofy. So basically we just pick one of these quadrants that has something that's not a 1 in it, and we're just going to interpret it. Okay. So in this case, we have a Pearson's correlation coefficient of 0.03. That means that that's a positive but very weak relationship between a community level's IMR and the average percent of residents without a high school diploma. Okay, so it's positive, but it's very like weak. If it were any weaker, the correlation coefficient would be 0.00. Okay. And the significance value on it is 0.794, which means it is not significant. So like the thing to say about this is that there is a weak association between community level IMR and the percent of residents without a high school diploma, and that relationship is, I'm sorry, what did I start with? I said there is a weak insignificant association between average IMR and percent of residents without a high school diploma. Okay, so it is very like blah. So we could go back up and we can look at one of these other ones, say per capita income, and we'll look at start with a correlation coefficient. It's a negative 0.43, and there's like different verbiage on what is strong, what's moderate, what's like, yeah, it's mostly between like strong and moderate and weak. Okay, so let's just say that anything above 0.8 is considered like super strong, like nobody's ever gonna like fight you on whether or not something that's 0.8 should be considered strong. Okay, it's everything less than that. It's everything less than that always causes a problem. So you could say with this correlation coefficient that it's a moderate relationship. Okay, so you could say community level infant mortality rates were moderately negatively related to average per capita income in Chicago community areas or in Chicago. So as per capita income goes up, the average infant mortality rates for community areas tends to go down. Okay, and that is significant at the 0.01 level. Next, and I'm not going to go through all the variables. I'm just going to like do several examples because otherwise this video would be 8 hours long. So for this next example, we would say that there is a moderate, or we could say moderate relationship between community level infant mortality rates and the average Gini coefficient. You could say that it's a moderate negative relationship or a negatively moderate relationship, something like that. And it's significant at the 0.00 level. We could also say that's less than 0.001. So there is a less than 0.1% chance that these results were achieved by chance. I got some bomb ass variables here, so like they're mostly significant. So this other one, same deal. There's a strong negative relationship or a moderate negative relationship. I'd probably go moderate negative here. Relationship between infant mortality rates and the average percent of foreign-born in a community area, which is interesting. That's something we know that's been documented in the public health literature and in the demographic literature, that some groups, some subpopulations have lower infant mortality rates. And so what this is showing is that community areas with large percentages of foreign-born population, or large percentages of foreign-born people, that's associated with less infant mortality. So those community areas with large foreign-born populations tend to have lower infant mortality rates. Now remember, the correlation, what we're going to do with correlations, and as like I show how to do this or why, and stipulate all of that in the Word document. So like what we're going to do with those results is we're going to basically just add a sentence to each of our descriptions of the scatter plots. Okay, now there is a little bit of a twist here, because we also need to do this for the Spearman's correlation. And we could do that by going to Analyze and Correlate and do bivariate. And instead of having Pearson, we just select Spearman. Okay, now I have tried to get them to both run at the same time, but they don't. So just save yourself the heartache and just go back out of it, deselect Pearson and select Spearman. And then make sure you grab the syntax and paste it into your syntax. And I'm going to throw a label on here and say correlations Spearman's. Okay, so we're also going to just copy and paste that out. So that's 5. All right, so last one's going to be last one's going to be high school diploma. That'll go there. And then second to last will be per capita income. That'll go there. Third will be Gini coefficient, and that will go there. Second will be non-Hispanic Black, and that will go there. Okay, so it is entirely possible that you run all of the Spearman's results and they are all significant as well. Okay, the Chicago Health Atlas data on some variables, they are different depending on whether or not you do a Spearman's test or a Pearson's. Sometimes they are not different, that they're basically the same. So for us, what we're going to do when we describe these is if there are diverging results, you mention that. Otherwise, you could just say both parametric and non-parametric correlation analysis indicate significant correlations between blah and blah. Okay, so you could just say that as well. So the only reason to mention by name both Spearman and Pearson's is if your correlation analysis is different. So if you have significant results on one but not significant results on the other. The correlations will be different. They'll probably be very similar, but it's like they're going to be off by a couple tenths. That's okay. We're not going to consider that different. We're just going to say they're both significantly related. Now, if one is positive and one is negative, you should definitely say something about that, but that's not going to be most of your situations. Okay. All right, so those are the correlation coefficients. Now remember, what we're going to do with these is we're going to come up with a sentence based on that information, and we're going to add it to our scatter plot paragraph. So by now you should already have written a paragraph of describing scatter plot between infant mortality rates and percent foreign born. Okay, probably say something like there appears to be some type of linear trend or linear pattern, whatever. The sentence you would add is, at least for our results, we would say, where's let me get that first one, foreign born. Okay, so the Spearman's results are significant. It is a negative relationship. Okay, if I go to my first correlation though, my Pearson's were significant. Which one was not significant? It was it was a high school diploma. Okay, so the high school diploma for Pearson's was not significant. If we go down to the high school diploma for Spearman's, it's also not significant. All right, so our sentence for the non-high school diploma might read something like, both parametric and non-parametric correlation analyses determined there were not significant associations between community level infant mortality rates and the average percent of residents without a high school diploma. That's all you need to say. Okay, and you don't really have to get like too worked up about the correlation coefficients themselves. You can always just say something's moderately strong, like moderately related, strongly related, weakly related. That's all fine too. You don't necessarily have to go back to the actual correlation coefficients. But some people like to have the option to do that because it can be repetitive to always be writing these for you're gonna have to do it for 5 paragraphs. So yeah. Okay, so your correlation analyses are basically going to produce one sentence for each of your scatter plots. Okay, and that's that. So you want to make sure you have your syntax copy and pasted into your syntax file. All right, so the next up is we have to create our north side, south side variables. All right, now this is somewhat of, I think this is the most difficult thing to do in this project because some people just kind of have a little bit of a block on it until they actually start doing it, and then it becomes kind of apparent. And that's all great, but it's also a place where it's easy to make accidents. Okay, so or mistakes. So what we're going to do here is we're going to make our first variable, and it's going to be a we're going to do a north side south side measure. Now for your convenience, I have included a map in the instructions file. It's one of the reasons why this damn thing is 22 pages long. But this includes all of the community areas in Chicago and their sort of assignment to quote unquote sides. Okay, so the far north side is this like salmon colored pink. It includes like Rogers Park all the way out to O'Hare, and that's the far north side. And then you have the north side, the northwest side, you've got the west side, central area, south, southwest side, far southwest, far southeast side. Okay, now for us, like all of these numbers correspond to community areas. 1 is Rogers Park, 76 is O'Hare, okay, 77 is Edgewater. So we don't necessarily care about the colors here, we care about the numbers. All right, and each of you are going to have to come up with a conceptualization of what you consider the north side and what you consider the south side. Okay, now I don't want to be the person that like spoils it for you, but the loop is it's mostly affluent people that live there. Okay, rich people who live in the high rises downtown, like they're affluent. All right, they are going to look a lot more like, and those community areas are going to look a lot more like community areas on the far north side than they're going to look like the south side. All right, so for me, what I want to do is I want to keep them, the 3 community areas in the central region, I'm going to keep them on the north side, mostly because if I put them in the south side, it's going to be super noisy, right? And like it's going to draw all the other characteristics, like all the other statistics for the south side. It's going to draw them up, and it's going to just look weird. Okay. And there's only 3 of them. Okay, so what I'm going to do for my conceptualization, I'm going to make 8, 32, and 33, they're definitely going into the north side. All right, the other question I have is the west side. All right, now there are some poor areas on the west side. There are also some areas on this in this area that have large proportion of people who have a lot of bad health. Okay, so they could go on the south side for that reason, but there's also some pockets of like real affluent people on the near west side. So I'm thinking of like Ukrainian Village and Pilsen and Logan Square, these places that are like super gentrifying right now, and so socioeconomically they might look a little bit more like the north side than they do the south side. I would argue that their proximity to the central part of the city makes them a lot more like the north side than the far southeast side. Okay, like have you ever ridden from, you know, I don't even know what community area this is, 50, like whatever 54 and 55 are to the loop? It takes forever. Okay, so I would argue that this west side, due to access to healthcare, access to resources, access to a lot of stuff, that they are just going to be like so much more, they're going to look a lot more like the north side. We're going to separate them out and do like our own separate west side analysis later, and we'll be able to play that out a little bit more, but for right now we're going to just like let them go in with the north side. That's my argument. You could have a different thing that you're doing. You could say west side should totally go in the south. That's cool too. It's going to be different for all of us, okay? Or it might not be. It might be very similar. It's fine, okay? Regardless, I'm going to take this and go split screen here so that I can have SPSS up here, okay? I'm going to start with my frequency distribution here. And when we do this, my output window is there. Okay, it's basically just showing us like all the community areas in Chicago. It goes from 1 to 77, but you knew that. Okay, what we're going to do now is we're going to click on data, we're going to click on transform, and click on into different variables. Now what this is going to do is this is going to allow us to create that new north side measure, and we're going to base it on these community areas and just kind of like what I've just been talking through. All right, to start, we're going to find our ID variable, this ID num, and move it over. And we're going to give this thing a new name. We're going to call it north-south side. Okay, now remember, when you name a variable, it can't start with a number and it can't have any spaces, and don't let it have any weird characters. Okay, for the label, we're going to call this something like what did I put in my, see, I already did this, so I just wanted to see how I did it. North side and south side. Type north side and south side. All right, that's cool. And then click on change. Okay. Now, part of the problem with this is I've already done it, so it gave me that weird error message. All right. If you haven't already done this, it's not going to give you the error message. All right, and that's your business, so don't even worry about it. All right. Next thing we have to do is we have to click on the old and new values. And this is where we take this little window and we're going to tell SPSS how to work with this new variable. Okay. So we're going to take the numbers that we think apply to the north side and we're going to put them in here. Okay. Now there's a couple of different ways to do it. All the old values go in on the left side and the new values are going to be on the right. Okay. So I'm going to start with a range. I've got 1, 2, 3, 4. All right, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. All right, so I'm going to go 1 through 22. Okay, and then we're going to make this equal to 1 on my new variable. All right, and then we're going to click add. Okay. And then we have 23, 24, 25, 26, 27, 28, 29, 30, 31. Okay, so we're going to do the same thing. We're going to go 23 through 31 here, and we're going to make them equal to 1. Remember, because I'm making north side all equal to 1. All right. Next thing we're going to do is we're going to grab 32 and do 32 like this. Oops, I don't want to do it like that. We're going to do 1. 32 here, 1 here, and add. And we can also do 33 here. Now I could have done the down here with the range 32 through 33, but I decided to do it this way just so you could see how that other button works. Okay, it's the same. All right, so I've got 1 through 22, which basically takes care of all of this, and then 32, 33, and then 23 through 31. The last ones I have are 77 and 76. All right, so let's do 76 through 77, make them equal to 1. And that's great, but what I also need is I need to have something for all the other community areas, okay? I need to have like 34, 35 through 60, all of these, they all need to be coded as something. So we're going to click all other values and we're going to make them a value of 0, okay? And then we're going to click continue, all right? And now we're able to click OK. So here's my syntax. I could copy and paste that into my syntax file if I were so inclined. I'm going to go ahead and I do this variable labels command. Sorry, value labels command. So I say value labels north south side, which is the same name as the variable I just created. And I'm saying if it's 1, I want to call it north side in single quotes, and if it's a 0, I want to call it south side. And then I get the frequency on it. Okay? And there we go. So we run the second frequency to make sure that we coded all of our community areas. So if I'd gotten anything less than 77 here, or if I had had like south side 40, north side 35, and then a couple others in here with numbers, that would have been my clue that I forgot to include a couple of them when I was coding them. Okay, so what you need to do is just like go back and fix it. All right, so come back into this, like go through the numbers, count them out, make sure that you have all of them included in your code. All right, so that part is done. And then so like that's great, but the next thing we have to do is we have to do it for the west side too. So we make another variable, and this time we're going to call it NWS side, okay? Now, when I did this, actually, let me go ahead and do it again. Transform, recode into different variables. Do reset. Okay, so I'm going to do ID num goes into here, and we're going to call this NW side. Label it, call this north, south, and west side community areas. Change. Again, same deal as last time. I already did this, and so I'm getting this message, but it's all right. Just go ahead and click through. All the new values here. Now here I did, let's see. Let me move this over. Actually, let me cancel that. I want to move this back so I can see my map a little bit better. Okay, so all the new values, same deal. I'm going to say 1 through 4. Oh, that's annoying. I kind of want this to be over on my other screen. All right, so 1 through... Just trying to get what I'm doing here. Okay. All right, so we're going to go 1 through, oops, use the range here, 1 through 4. Okay, they're going to be a 1. And then 9 through 14, also going to be a 1. Okay, and then 76 and 77, also going to be a 1. Okay, and then we have 15 through 20. Oops, 15 through 20, they're going to be 1s. And then 5 through 7. 5 through 7, also going to be 1. And then 21 and 22 also. Okay, so it takes care of all of this. Okay, I also want to grab community area 8 because we're going to do that with this. That's a central area. We want it to be a 1, and then 32 and 33 also. Okay. Cool, cool, cool. So that takes care of the central. All right. So we've gotten 76 or 77. Oh yeah, that's right. So I've gotten all this dark pink, purple, green. Did we get 32 and 33? Yep, we got those two. Okay. So that's going to be the north side. The west side is easy because all we really need to do for it is that green section, which is, well, this is very annoying. Let's see if we can make this go full, trick this into half screen. Okay, so it wasn't green, it was orange. And they're 23, 24, 25, 26, 27, 28, 29, 30, 31. Okay, so here we're going to go 23 to 31. Like in the interim, I just had to move my computer, and so I lost my double screen, and now like every time I click on the map it goes away because it's super annoying. Okay, so we've got 23, 24, 25, 26, 27, 28, 29, 31, and they're all going to be on the west side, so we're going to give them a 2, and then we're going to add them, and again we can make all other values equal 3. Okay, so we have our new variable is going to be coded as 1, 2, and 3. And what we've done is we've taken those 77 community areas and mashed them down. You could think about it a couple different ways. We mashed them down into 3 categories for our northwest and north side, south side, and west side variable. Or we could say, you know, our new variable has 3 buckets. And so we kind of basically just distribute all these community areas to different buckets. Either way that helps you think about it is fine. Okay, so we're going to add that, and then we're going to hit continue. Okay, and we're going to do okay. Okay, now remember, whenever you work with a new variable or you're creating a new variable, all it does is it just tells you, SPSS tells you that it did it. It doesn't actually like do anything else. So we have to ask for a frequency on it. Actually, we're going to go ahead and label it first and then ask for the frequency. All right, and so that's what we have. We have 26 community areas on the north side, 9 on the west side, and 42 on the south side. Now, is it a problem that the west side only has 9 community areas and the south side has 42 and the north side has 26? No, it's not a big deal. I have very few problems with that at all. From a statistical analysis perspective, we could always run into problems with if we were going to do some type of sub-analysis based on only the west side community areas, because only having 9 that's quite a small number, but so far we're not going to be doing anything like that. So we're just going to let it ride. It's perfectly fine the way it is. All right, so we've got our north side, south side variable, and then we also have our north side, south side, west side variable, okay, which means that we are ready to do our means comparison test. Okay, so if we kind of scoot forward here, past this, and I actually include a dummy here to show you some of the problems that can arise when you are not doing a very good job coding. The screencast does not have it in there because I couldn't remember the mistake that I made and I couldn't get to it, so sorry. Okay, means comparison table. Basically what we're going to be asking for now is we're going to say to SPSS, give us a means report on our 6 variables, our dependent variable and our 5 independent variables. We want to get the mean values for our north side, south side, west side community area measure. Okay. All right. So we're going to get to that by going analyze and compare means and then click on the means. Okay. And since I already did this, they're already there, but I'm going to like reset it so you can see what it looks like. We're going to use the three-sided measure for this means comparison table because actually I don't have a good reason. I just arbitrarily chose it. Yeah. Okay. Once you've got your three-sided measure in the bottom window, let's get all of your other measures in the top window. Okay. Now remember, in this situation, we're working with all of our new variables. Okay, so these are the ones that we created in Mini Project 1, and they should already be labeled and good to go. Once we're here, we're going to click on Options, and we're going to take the standard deviation out of that right window, and we're going to put in the minimum and the maximum. Okay. So when, in addition to reporting the n and the number, the n, which is the number of cases, and the mean, it's also going to give us the minimum and maximum values for each of those variables. Click Continue and OK. Okay. Now this output gives us two different pieces of information here. The first is a case processing summary. And this basically just tells us how many observations were included for each of our variables. They should all say 77. Okay. If anything, you might have a situation where if you've fallen down on the job coding your three-sided categorical measure, so like let's say you left out some community areas and you only end up with say 75 or 74 in this space right here, you just have to go back to when you created that measure and modify it. So go in and make sure that all the community areas 1 through 77 are reflected in those parentheses. Okay. And like you'll have several terms, like 1 through 4 equals 1, 21 through 25 equals 2, or whatever. Okay, so just make sure that 1 through 77 is reflected in all of those multiple terms with the parentheses. Okay, and then so the top table we don't care too much about, other than to make sure that all the numbers that pop up in here are 77. All the numbers in the second report, or the second table here, is all of our variables, and then we get them as summary measures for the north side, the south side, and the west side. Okay, so this first column gives us the mean IMR for the north side, and then we get it for the west side, and then the south side, and then we get a total mean. Okay, and then we get the same thing for average % foreign born, average % non-Hispanic Black, average Gini coefficient, average per capita income, and average % of residents without a high school diploma. Okay, so on the north side, on average, the communities on the north side averaged 13.06% of residents without a high school diploma. For the west side, that was 25.48%, and then for the south side, it was 19.4. Okay, so what we would want to do is we want to take this table and copy it and put it into our Word document. Okay, because this thing, we're basically just going to keep cobbling pieces together for this document. Course project, Mini Project 2, I think it was this one. Oh, false. You know what? Actually, it would work because it already has all my tables in it. Does it have my yeah, it does have my scatter plots. Or does it just have the one? That's kind of annoying. Let's look and see if there is a different document in here. Course projects. Anything in here that's like a little bit newer? 524. Oh, scatter plots. Nice. Okay. Oh. Well, not in love with this output, but it'll work. Okay, so what I'm going to do here is I'm just going to paste this means comparison table in the document. Okay, now it can be a little fussy to work with. So I just pasted it, and it is off the page, per usual. That's just like what it does. So this is going to require like some hand holding by me. I'm going to have to, like, I don't know if you saw what I did just now. I grabbed this little button here and I'm like changing the width of the table. Okay. Also, like all of these numbers we don't need to have like carried out to 4 or 5 decimal places. So I'm going to try, I'm going to have to do it some other way. I might have to paste it into Excel first. I don't know. Yeah, so some of these I probably would make a little bit narrower. You know, it's very ugly right now, but it's in there. So I would spend some time cleaning this up before I turn it in. Okay. So next up for the project, we have the means comparison table is done. Now we're up to hypothesis testing. So we're going to work through a couple of examples with this, and we're going to put the, we'll take the 2-category measure for north side, south side. We'll work through a couple examples with the Independent Samples T-Tests and the Mann-Whitney U. And then we'll do the same thing with the 3-category measure. We'll work a couple examples with the Anova and the Kruskal-Wallis. So I'm going to copy my syntax because I can't remember if I did this already. I did not, so there she blows. And I'm going to save my syntax because, you know how it be sometimes. Okay, so what we want to do now is we want to start we'll start with the Independent Samples T-Test, okay? And we're going to use, remember for that, we're using the 2-category measure. That's the north side, south side variable. So we're going to click on Analyze and then drag down to Compare Means, and then we're going to click on Independent Samples T-Test. Okay, now we're going to use our new measures. All right, so our north side, south side measure goes into the grouping variable, and then we're going to start with infant mortality. It's going to go in the test variable window. Okay, so in this, for the 2 types of tests that we do for the 2-category tests and the 2 types of tests we're doing for the 3-category tests, we are not focusing on the nature of the relationship between the independent variable and the dependent variables. Let me rephrase, the dependent variable and the independent variables. Okay, we're not focused on that relationship at all. Right now, all we're looking to demonstrate is the differences between community areas in terms of the variables we've selected. Okay, so we put our infant mortality rate variable in the test window, and then our grouping variable goes in here. We can't click OK yet because we have to define the groups. So if we click on the gray space and then define groups, that gives us the chance to put in our values here. Now I did 1 and 0, okay, because that's just how I roll. But it's possible that you didn't know to do that. You might have done it as 1 and 2, and that's completely fine. Okay, 1 and 0, 1 and 2, they basically do the same thing. So if you do this and you get weird results, like maybe you don't remember it, but maybe you coded your north side, south side variable as 1 and 2 instead of 1 and 0. Just go back and redo this part with 1 and 2. Okay, so we do continue and then we do okay. All right, so with the analysis, we get 2 pieces or 2 tables. Okay, the first is a group statistics table. This gives us the mean for the north side and the south side of our variable that we included. So it's IMR. The mean IMR for north side communities was 5.54 deaths per 1,000 births. The mean for the south side communities was 10.07 deaths per 1,000 births. Okay, now the next thing, it gets a little tricky. I'm not going to lie. All right. First, you have to remember that with the Independent Samples T-Test, it's a parametric test, which means that there are parameters that are sort of requirements or assumptions of being able to do an Independent Samples T-Test. All right. So what SPSS does is it runs a Levine's test as part of the Independent Samples T-Test results. Okay, and the Levine's test simply offers a hypothesis test on whether or not the variances are equal. Okay, so that's one of the sort of requirements of doing an independent samples t-test, is that the variances of your two categories are equal. All right, if they're not equal, then that changes the row of data that you interpret. Okay, so basically we get results for two conditions in this table. Whether or not we assume equal variances, that's basically, it dictates what row we work with. Okay, so if we can assume equal variances, we work with the top row of data. If we cannot assume equal variances, we work with the bottom row. Okay, now how do we read the Levine's test? The Levine's test results are these first two columns of this table. Okay, all we're looking for here is the significance value. All right, the significance value of 0.003. This is the result of a hypothesis test asking whether or not the variances of our two groups are equal. Okay, now if you remember what the hypothesis test, our null is that they are equal. Okay, that happens to be the condition that we want here, but that's neither here nor there. All right, the significance value, with the significance value of the Levine's test, anything that's less than 0.05 means that we do not have equal variances and we have to interpret the bottom row. Okay. Anything that's greater, if this significance value for Levine's test is greater than 0.05, then we have equal variances and we can interpret the top row of data. All right. Now, this is very confusing. I know. Okay. That's all right. It's been my experience with this data that 85% of the time, it doesn't change the results. Okay, so once we've moved past this, our next step is to look at the significance column for the t-test results. Okay, they're both the same. So whether I interpret the top row or whether I interpret the bottom row, it doesn't matter. I get the same result. Both results say I should reject the null hypothesis. It's very few, it happens very rarely that one is going to tell you to reject the null and the other one's going to tell you to retain the null. Okay, just know that. All right, so the first step is to note what the means are in the group statistics table. Second step is to interpret the Levine's test results. This significance value for the Levine's test of equality of variances examines, or actually it tests, whether or not the variances of our two groups are equal. Okay, a value that is 0.05 or less indicates that they are not the same. The variances for the north side are not the same as the variances on the south side. So we have to interpret the bottom row. But if they are the same, then that will be indicated by a significance value up here of 0.05 or more. Once we get past that, we're then just left to interpret the significance value in the sig two-tailed column. So if we determine we needed to interpret the top row, we're going to say that there is the significance value is less than 0.001, which means there is less than a 0.1% chance that these results were achieved by chance. Okay, so this mean difference between the north side and the south side is significant. These means are significantly different from each other, which you would guess. I mean, one is almost twice the other one, right? Okay, let's do one more of those because it is exhausting. It is also midnight. All right, let's get to our syntax. So we did the north side, south side. I'm going to skip down to the non-high school diploma one only because I think that these other ones are all significant and I want to give us a chance to interpret the non-significant ones. Okay, so this is testing the percentage of individuals in the percentage of community areas. Let me rephrase. The no high school diploma measure is the percentage of individuals in a community area that do not have a high school degree. Okay, for Northside community areas, it's 16.25, meaning that Northside community areas, their average percentage of residents without a high school diploma was 16.25. For Southside, that was 19.4. So almost 3% difference between the two. It's not very big, but big differences aren't necessarily statistically significant. And that's why we do the statistics, to actually check. Okay. So our first part of this, Levine's test, we have a value, our sig value here is greater than 0.05, which means that we can interpret the equal variances row, the top row. So it being greater than 0.05 means that the variances between the north side and the south side on this variable are comparable. Okay, cool, cool, cool. And then for the sig two-tailed column, the significance values for the t-test, we have 0.205, which is not significant. Remember, anything that's 0.05 or less is significant. So in this test, we are learning that the two means for the north side communities and the south side communities are not significantly different from each other. The difference is, less than 3, and it might as well be 0. They might as well be the same number. So that's what we're getting out of the independent samples t-test. Now, yeah, and I'll be able to talk more about that during our office hours if you'd like, but this is a pretty cut and dried response. Cool thing about the Mann-Whitney U is that we get very little output for it, and SPSS goes ahead and tells us what to do with it. All right, so to do the Mann-Whitney U, we're going to go click on Analyze, and then so with the Mann-Whitney U, what we do is we click on Analyze and then drag down to non-parametric tests. And what we're looking for here is the independent samples test. Now, in this window, we get some very basic sort of assistance with what we're trying to do. Basically, we're going to put our group variable, which is a north side, south side variable. That's going to go in the group window. Okay, so that goes north side, south side there. And then infant mortality is going to go there. Okay, and then it's just a matter of running. Okay, now we get this syntax, then we also get this output where it gives us the significance value and then the decision. Now this decision is based on a significance level of 0.05. Okay, now we could change that if we wanted to. We could make it 0.10 if it were sort of required or something, but that's a very rare circumstance. We typically work with significance values of 0.05, so we would set our alpha at 0.05. All right, so let me get to this syntax. That gets pasted in here, and then working with our syntax going forward, we're just going to swap out the first variable that's in the first term. So IMR, foreign born, NH black, Gini, per capita income, and no high school diploma. Okay, all of those good to go. All right, so we basically just did the non-parametric equivalent of the independent samples t-test. Okay, all of these I think came back as significant. I might be wrong. So you've got reject, oh no, the last one, the no high school diploma. The significance value there is 0.086, which is greater than our alpha threshold of 0.05. So that tells us that we need to retain the null hypothesis. There are no significant differences in the distribution of the two groups, the north side and the south side distributions of no high school diploma. They look indistinguishable from each other. They might as well be the same number. That's how close they are. So they are not different. The rest of these, though, are. Whenever we get the reject the null hypothesis message, that's telling us that the north side and the south side have significantly different distributions on things like infant mortality rates and the percentage of foreign-born residents, the percentage of non-Hispanic Black residents, and the average Gini coefficient, as well as the per capita income. Okay, so that is that. Next up, I think we are set to do our ANOVA. Now the ANOVA is fun because you get like a lot more limited output than you do from the t-test. How you get to the ANOVA is you click on Analyze and Compare Means, and then you drag down to the one-way ANOVA. Okay, now in this window we're going to put our north side, south side, and west side measure in the factor variable. That's going to be, you know, that's where we're at. That's where we are. That's what we're working with. Okay, we're working for ANOVA and the Kruskal-Wallis H test. They both use the north side, south side, west side measure. Okay, now we're going to start with infant mortality for the dependent list. Now we're also going to do a quick little thing here where we ask for a post hoc test. If you remember from the textbook, the post hoc test is only, let me rephrase, Tukey's post hoc test, it's the HSD test, is only run in the event that we get significant results in our ANOVA. Okay, and what it will do is it's going to like bring out a comparison, a head-to-head comparison of all of our groups. So it'll compare north side to the south side and compare north side to the west side, and then it will compare the south side to the west side. Okay, and it'll determine which, if any of these comparisons are significant. Okay, so we're going to go ahead and select Tukey and continue, and I think we're good to go here, so we'll also say okay. And you'll notice in our output, in our instructions file, that like there's, you know, detailed instructions on how to do all these things. Okay, I should mention it because I just scrolled past it. I asked for a table of t-test results. That's what you have here. Okay, and then for the ANOVA, that is where we are right now. So when we do the ANOVA asking for the Tukey's results, we get 3 tables. The first is the ANOVA results. Okay, these test the means of the 3 groups and determines whether or not any are significantly different from each other. So the significance value of 0.000 indicates that there is at least one of the groups that is significantly different than the other 2 in terms of infant mortality rates. Okay, and then the second table is the post hoc test that we just ran. That's a Tukey's. If this first table had not been significant, we wouldn't see this part. Okay, so what this does is it does a head-to-head comparison, north side, south side, and then it gives us a significance value. So it's showing here, because this thing is less than 0.05, that the north side was significantly different than the west side. And because this next one is 0.000, the north side is significantly different than the south side in terms of infant mortality. Okay, and there's more about this in the instructions file. And because of the way groups work, half of this table repeats itself. So like this 0.579 and this 0.579, it's for the same west side, south side comparison. So what this table tells us is that the north side is significantly different from the south side, and it is significantly different from the west side. The west side and the south side are very similar. Okay, so the significance difference that makes that ANOVA result pop is the difference of the north side versus the south side and the west side. That's the group that's significantly different than the other 2. This homogeneous subsets, we're not going to worry about that. Just skip over it. Okay, let's do this one more time. Let's grab this syntax and head over here to my syntax window, paste, 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 and then swap out the variable. Okay, so the second variable is going to stay the same, the northwest or NW side measure, all the same, and then you're just swapping out the first variable. So let's do that. All right, let's see if there's 0.04, 0.00, 0.00, 0.00, 0.03. Okay, so it looks like, let's use this one. The percentage of non-Hispanic blacks in one of these areas. So we get our first results, we have significant ANOVA results, which says that at least one of the community areas in this analysis is significantly different than the other two. All right, and when we look at the post hoc test table, we see that north side and west side is significant. North side and south side is also significant. Okay, so there is a significantly different percentage of non-Hispanic blacks in the north side communities versus the west side communities and the south side communities. So if we pop down here to the last row, we see that south side, north side is significant, has less than 0.05 here. And then south side and west side is not significant. So that result tells us, again, that the south side and the percentage of blacks, the percentage of non-Hispanic blacks is not significantly different from the west side than it is the south side. Okay, those two are the ones that are essentially the same, and it is the north side that's very different for the percentage of non-Hispanic blacks. All right, so that is the ANOVA with the post hoc results. Now the last thing to do here is to get the Kruskal-Wallis H-test results. Now it's similar to the Mann-Whitney U in that you go to Analyze and then drag down to non-parametric tests, and we're going to hit the legacy dialogues part here and drag over to K independent samples. Okay, so K here stands for like any number of independent samples. So if you wanted to do 10, you could do 10, you could do 12, you could do 15. It doesn't really matter. Okay, whatever number of categories you have, that's the number of categories you can do in this analysis. So let's reset this and go with our north side, south side, and west side variable as the grouping variable. And then we're going to go IMR for our test variable. All right. Now we need to define our range here, and by clicking on the gray window and then clicking define, we could say the minimum value for our group is 1 and the maximum is 3. Okay, because 1 was the north side, 2 was the west side, and 3 was the south side. If you had done it differently, like maybe you did 0, 1, and 2, you just put 0, 1, and 2 in here. All right, that's your business. So just do it. Okay, so click continue, and then we want to make sure that the Kruskal-Wallis H-test is selected, and click OK. All right, now there's the feedback is, it's abbreviated. There's not much going on here. The first table gives us a summary ranks table, and what it tells us is that when IMRs are ranked from least to the most, if you pull out the north side community areas, their average rank would be 21.10. Okay, where like the lowest values, that's the beginning of your list. All right, west side is over twice that. So if you took the ranks of west side communities and you figured out an average, their average rank would be 43.22 in terms of infant mortality. Okay, and what you could say is that they are ranked, yeah, that's how you would do that. And then the south side community areas, their average rank was 49.18. All right. This asymptotic significance at the bottom of this table, it's 0.000. That is significant, telling us that these different groups have significantly different distributions of infant mortality rates. Okay, remember the non-parametric tests, because we use them when our data are not ideal, we use them when we might have, skewed data, or when we might have like small data. We don't mess with the means. The non-parametric tests are working with medians. Okay, so in this case, like we would not be talking about the mean infant mortality rate on the north side. We talk about the mean rank infant mortality rate on the north side and the south side and the west side. Okay, so if you copy and paste that syntax into your syntax file, 1, 2, 3, 4, da 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 da, and then swap out the first variable. So I went from IMR to foreign born to non-Hispanic Black to Gini to per capita income and non-Hispanic or no high school diploma. All right. If you are working kind of similar to the way I work with your syntax, you should have, getting up there in a couple hundred lines of code. You're likely looking at maybe 200 lines like I have. You might have more, that's okay. If you have a lot less than that though, I have some real questions for you, because it means that you're probably not bringing all of your syntax in when you're supposed to. So let's get on that. Make sure you save your syntax, and you'll be submitting this when the time comes. And yes, so the project file has some just some notes on what is required for each of these steps, right? You get the ANOVA. I ask you to combine all of your ANOVA results into a table, and then I kind of walk through the types of descriptions you're going to do. Once you get your ANOVA table and once you get your t-test table and your means comparison table, you're basically going to write I think I said 12 to 14 paragraphs, 13 to 14 paragraphs. You can do 1 or 2 paragraphs on your means comparison table. Now, again, consult the project file. Don't describe every single cell in the table. Nobody wants to read that, okay? Your job as a statistician, as an analyst, as a person that knows how to work statistics and SPSS, your job is to summarize that information, okay, and communicate it effectively and efficiently. So basically, when you're writing it up, you want to talk about the trends, the sort of overall patterns that you're noticing, and leave it at that. Once you do that, you're going to then write up 1 to 2 paragraphs on each of your variables. Okay, so I think you could do 2 paragraphs for each variable, 1 on your 2 category test and 1 on your 3 category test. Now, again, consult the document here, but what's with the spelling? Why is that so bad? So, like I was saying, you'll write 2 paragraphs on each of your variables. 1 will be about the 2 category tests that you did, and then the second paragraph will be on the 3 category tests you did. Basically, these paragraphs do not need to be very long. Basically, I've given you a couple of examples here. Talk about whether or not the parametric and non-parametric tests gave you different results. Try to include a couple of numbers in there to help make it real, but you don't need to go on about every single statistic that was included in the analysis. So that's that. Again, we're building this document up with the idea that you're going to be submitting it at the end of the quarter. The final project will be some regression modeling. What we're going to do is we're going to do linear regressions and I think six or 7 different models, but we'll basically distill it all down to 1 table with 2 paragraphs as a description for that. So the bulk of the writing for this is actually for mini project 2. 13, 14 paragraphs is a lot, but if you get it done now, if you get all the analysis done and get them slapped into a Word document, then you can every week write up a couple write up a couple of the variables and just basically move it forward. The idea is that when we do mini project 3, you won't need to create any new variables. You already have done that. So it'll just be a matter of doing the regressions, pulling out the statistics that we need, slapping them into a table, and then writing the 2 paragraphs. So by the end of the quarter, your document will have the 5 scatter plots plus the 5 paragraphs. I'm sorry, the 6 scatter plots and the paragraphs describing them, the 6 paragraphs, and then 13, 14 paragraphs describing the hypothesis testing, and then 2 paragraphs with your regressions, and then your tables and figures, however large they end up being. It'll be fine, whatever it is, I'm sure. If you get a chance to get started on this before class on the 15th, cool, that's great. Bring your questions to class. I'm hoping, I was trying to get your review of your syntax files done already, but I haven't gotten to it. I'm not quite done, so hopefully that'll be done tomorrow, and that will be back to you, and you can start. So if you have any questions or concerns in the interim, just send me an email. If there's anything that's not clear, let me know, and I'll try to fix it. All right, thanks. Good luck.